Greetings and welcome, friends. We were talking about solving systems of linear inequalities yesterday, and instead of graphing a single inequality on a coordinate plane, we graphed multiple, and then we described our solutions as being the common points of intersection between those. So here's a question they're asking: is this point a solution of this system? And the question would be, does it work in both of these? So if I plug in -1 for y, I would have -1. Is that greater than -2? True or false? -1 is bigger than -2. That's less debt to owe somebody. Plug in -1 for y here. Is -1 greater than, plug in 1 for x, -5. Is -1 greater than -4? Also true. So because that's true for both of those, then it's true for the system. All right, solution of system. So it has to work in both of those simultaneously. All right. Cameron, you got your packet out? I didn't see yours when I was walking around. So here we go. Then we were graphing these problems. Y greater than -3 is going to be a horizontal line. You could think about that as having slope of 0. It passes through -3 here. It's a horizontal line. Is this solid or dashed? How do I know? It doesn't have the equal to part on the inequality, so you guys are correct. It's going to be dashed. Oh, I just lost. There it is. Okay, we'll follow along either way, right? Learn, right? That's always a good idea. So let's see. So I've got a dashed line, and which way do I shade? Y is greater. Yeah. So the Y values that are bigger than this line will be above the line, right? Yeah, I usually do 1 blue, 1 purple. I did like these colors. Ooh, it's so pretty. So all of these blue points are solutions of that first inequality. But now I've got to graph the other one on top of it. So gentlemen, you with me? Eyes up at the screen. We're following along, asking questions, right? So for this one, actually, let me ask you this. Is this a horizontal line? No, this one's got a slope. What is the slope? Yeah, 5. What's the y-intercept? 0. Yeah, there's like a +0 there. There's nothing. So to plot that, I'm going to have y-intercept of 0, slope of 5. So I'm going to go up 5 over 1. Solid or dashed? Why is it solid? Because it has the equal part, right? And now, it would be wrong for me to ask, do I shade this left or right? It would be wrong for me to say that. This is a y relationship. It's saying y is greater than or equal to that. So y, being the vertical axis, Devin, this is going to be an up-down question, so shade above is what I do. So let's shade above the line, which, yes, I agree, looks like that's to the left, but above is the better way to think about it because this was a y relationship. All right, left and right is when I have an x by itself in the inequality. Well, okay, so I just had a student ask saying that doesn't look like it's above. So the points above 0 are right here. The points above this are right here. So it is above. It's just a really steep line. But yeah, so for a y relationship, Devin, last time, we don't need to ask whether or not it's left or right. Okay, so let's ask, let me ask you this question. What points are the solutions here? Well, the solutions are going to be the common shaded region. All right, let me ask you this. Is the origin a solution? Yes, because it's on the solid line. Okay, is -3 a solution? No, because it's on a dashed line. Right, so that one's a no-go. -3, -3. I can't even read that. Let's see. Someone give me a solution, a point that's a solution. Over 1, up 5. Yep, that's barely on the line. 1, 5. 1, -5 would not be. -1, 5. Yep. That's in the common shaded region. -5, 5. Yeah, that's a good solution right there. -6, 4, somewhere around here. Yeah, so those are solutions. Points that are not solutions would obviously be anything down here. That's not a solution for either. Anything here is a solution of the blue inequality, but not the purple. Anything here is a solution of the purple, but not the blue. Fuchsia, I don't know. We're getting some disagreement on the color. Feel free to comment in the video below what color that is. All right, so here we go. Second to last problem. If I want to graph these, I'm going to actually rewrite these in slope-intercept form. Actually, why not just do this second one first? How do I get the y by itself here? Subtract 2 both sides. I like it. So I'll have y is greater than or equal to -2x minus 2. So that is in slope-intercept form. Let's take the other one and get y by itself there as well. Oh, wait a minute, guys. Oh, did I have to flip that inequality when I subtracted 2? No, I only have to flip an inequality when I multiply or divide by a negative, right? How do I get this y by itself? Jimmy, what are your thoughts? Yeah. Subtract who? From both sides. Yep. So I got y is less than or equal to -2x plus 5. Do I have to flip that inequality? I put -2x in front of the 5 because I was thinking of mx plus b style, right? So let's see. Let's graph this first line. Y-intercept is at -2. The slope is -2. So where do I go from here? Nope. Slope is -2, so I go down how many? Nope. Down 2 over 1. -2 is the same as the fraction, -2 over 1. And then I can do that again. Down 2 over 1, down 2 over 1. Is this first line, I'll call this my blue line, is this solid or dashed? It's solid because it includes the equal part, right? Now, in a moment, we're going to be doing all of these skills backwards, right? You've got to know this inside and out. And which way do I shade this? Wrong. Yeah, I shade above. It's a y relationship. Y is greater than would be the points that are above. If you said shade to the right, I would still disagree with you because we were asking a vertical question. We were asking about the y. All right, so let's see. That's my best coloring. First, I draw this realistic head. Then I erase some of the more detailed features. Okay, here we are. Let's draw the purple line. What's the y-intercept? 5. Yep. And the slope? So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Solid or dotted? Solid. And actually, what can you tell me about these two lines, the boundary lines? They're parallel. How could I have known that from the beginning before I graphed them? Because they have the same slope. Man, woo! Ninja right here. This is awesome. We got, woo! Parallel lines have the same slope. Now, question, they want us to shade which way? Below the line. So, I'm shading below the line. Everywhere. Actually, this whole graph is going to look shaded. That's interesting. But does that mean everything's a solution? No. Where are the solutions? In between the lines. Yeah, I like that. In the middle is what the student said. So, is the origin a solution? Yes. Is 2 comma negative 3 a solution? 2 comma negative 3, solution. Is 2 comma 1 a solution? Yeah, it's a solid line. If it was dashed, it wouldn't have been. Is negative 2, 2 a solution? Negative 2, 2. Yeah, because that's a solid boundary right there. All right, here, Devin, you can be quiet. We're trying to work here. Thank you. Negative 5 comma 10. Is negative 5, 10 a solution? Yeah. Yeah, all sorts of solutions. So anything in between, well, there are some points that aren't solutions. Like 5 comma 5, over 5, up 5, not a solution. That would have worked for the blue line, but not the purple one. Yeah, only in the middle, yeah. So negative 5, negative 5, that's not a solution. Negative 10, 0 is not a solution. Negative 3, 1 is not a solution, right? Any point that is only in one of the shaded regions will not be a solution. 1, 1 is a solution, yeah. All right, so guys, let's use those same skills in reverse. Backing up, backing up, backing up. Here we go. So it appears as though my common shaded region, they only shade one area because really, like I said, we only care about the common shaded region. So those are the solutions that they're describing for us. And the goal, Jimmy, Devin, guys, following Cameron, right? The goal is to write the system of inequalities. So let's work with this solid line first. What's the y-intercept of the solid line? What's the y-intercept of the solid line? Give me a number. 1, thank you. How could I find the slope of the solid line? I need to find another lattice point that it crosses the grid at. It looks like this line is going up how many and over how many? It's going up 5 over 1, so the slope is 5. It's a solid line. Let's see, so for this line, it's going to be y. It's going to have an equal part. It's going to be 5x plus 1. And what direction is the sign? Well, it's a y relationship. So I'm shaded below the line. What sign represents below the line? Less than sign, yeah. So there's one inequality. All right, let's do the other one. Where's the y-intercept on the dashed line? Dashed line, where it be at? Yeah, I think it's negative 2. And the slope is 1. How do you find that slope? How did you know the slope was 1? It goes up 1 over 1, up 1 over 1, right? So slope is 1. Now, it's shaded above. So what sign should that be? Greater than or less than? Yeah, greater than would be above. Does it need an equal part? Why not? It's dashed, so it doesn't need the equal part. So notice how this problem is actually quite a bit trickier. You have to use all your skills in reverse to figure it out. Well, thank you for watching, Internet friends. Have a great day.